Now let us continue understanding the laws of precess with respect to the shrinkage of concrete. Now we already know what is shrinkage. Now the shrinkage is, as understood, is going to cause reduction in its volume. This reduction in volume because of shrinkage is going to shorten the tensioned wires and hence contribute to the loss of stress. On a detailed note, the shrinkage of concrete is defined as contraction of concrete because of loss of moisture. This contractions causes change in length per unit length, and therefore a dimensional number is expressed as percentage. So this shrinkage is going to change in its volume and it is going to significantly cause a change in the length per unit length. So it's going to be a strain. The shrinkage is a time dependent value and it is classified further as plastic shrinkage, autogeneous shrinkage, drying shrinkage, and carbonation shrinkage. Now, after grouping certain classes of shrinkage, the Indian Standard Code has recommended us to understand the or quantify the loss due to shrinkage of concrete with respect to drying shrinkage and autogeneous shrinkage. Now, as the code suggested, the total shrinkage loss may be computed by determining the strains induced by the concrete shrinkage. Hence, the total shrinkage is a sum of drying shrinkage and autogeneous shrinkage. Now, let us presume the total shrinkage strain to be equals to epsilon Cs. This epsilon Cs, the total shrinkage strain, is equals to epsilon Cd, which is drying shrinkage strain, and epsilon Ca, which is autogeneous shrinkage strain. Now, what is this drying shrinkage strain? Hydration of cement is an everlasting process. The drying shrinkage is also an everlasting process. The loss of free water contained in the hardened concrete do not result in appreciable dimension change. It is the loss of water which is held in the gel pores that causes change in the volume. Now, upon understanding what is happening with the drying shrinkage, now the code has suggested how do we take the drying shrinkage strain value. So let us first see the code has suggested the ultimate drying shrinkage strain value to be taken as epsilon Cd times alpha, which is equals to Kh times epsilon Cd, which means if you want to find the drying shrinkage strain at an infinite time, then it should be equals to the Kh times epsilon Cd. Now what is this epsilon Cd? Epsilon Cd may be taken from the code with respect to the characteristic compressive strength and the relative humidity of the site at which this member is located. Now, this is the table which is going to suggest how do I take the drying shrinkage strain value. The drying shrinkage strain times 10 to the power of 6 value is represented here for 50% relative humidity and 80% relative humidity. And it is also suggested that the coefficient of variation is about 30%. If you could able to exactly identify this value, you can identify and do the calculation. But if you are having no information about the experimental data, you may as well take this data from the code. So this is a drying shrinkage strain value. So this term we could able to identify. Now we will have to find out what is the value of KH. Now the value of KH, this KH is a coefficient which is depending upon the notional size of the member. Now if this notional size H naught is given as 2AC by U. Now if this 2AC by U value could be found with respect to this 2AC by U value, which is in the notional dimension, we can find out what is the value of KH. Let us further see what is this notional size. 2AC, in which AC is a concrete cross-sectional area and U is the perimeter of that part of concrete which is exposed for drying. For instance, let us see a beam. Beam top part will be concealed in the concealed with the slab or the deck, and the bottom part of the beam or the three sides of the beam will be exposed for drying. This is a normal scenario. Now, upon finding out the value of KH from identifying the H naught value, and also taking the value of epsilon CD, we can find out what is the value of epsilon CD infinity, which is ultimate drying shrinkage strain value. Now, if you want to find out this drying shrinkage strain value at a particular time, so if you want to find out this drying shrinkage strain at a particular time, then the code has suggested that value to be equal to epsilon CD at a particular time t is given as beta ds of t comma ts times kh times epsilon cd. If we can recall, kh times epsilon cd is epsilon cd infinity. Now, if we can, we have to initially find out what is the epsilon cd infinity, and we have to multiply it with a beta factor. Now this beta factor, beta ds of t comma ts is given as t minus ts by t minus ts plus 0.04 times root over h naught cube. Now in which T is age of concrete at the moment considered and Ts is age of concrete at the beginning of the drying shrinkage. It is normally uh, end of the curing time. So probably if we are casting some pre-tensioned members, we are going to manufacture that member or cast that pre-tensioned member in the casting yard, and we are going to cure it for some 10 days or 14 days. So after this 10 days or 14 days, the concrete is going to undergo this drying shrinkage. So the water inside the pores are going to get dried up, and this reduction or the moisture from the voids are lost will try to shrink the member. Now upon finding out this value, we can substitute this value directly and we can find out what is the drying shrinkage strain at a particular period of time t. Now we are done with only one term of the total shrinkage strain, which is drying shrinkage. Now let us see what is autogeneous shrinkage strain. Autogeneous shrinkage strain is nothing to do with the water, but this is going to happen because of the reaction between the cement and water, and this hydration is going to uh, change the volume of the concrete. Now, not because of drying of the water from the pores, but this is the water which is consumed because of the reaction between the cement and water, which is again termed as hydration. And because of this water is consumed, there will be a reduction in the member, and the concrete is going to shrink. Now, similar to the ultimate dry shrinkage strain, we also have a ultimate autogeneous shrinkage strain. This ultimate autogeneous shrinkage strain is dependent upon again the grade of the concrete which we use. Autogeneous shrinkage strain, these values are given in the Indian Standard Code. Similar to the drying shrinkage at a particular time, we can also find out the autogeneous shrinkage strain at a particular time. Autogeneous shrinkage at a particular time t is given as beta As times epsilon Ca. Now this beta As at a particular time t is given as 1 minus exponential of minus 0.2 root over t. Now we already know what is t. T is the moment considered for calculation of autogeneous shrinkage strain. So this concludes the determination of autogeneous shrinkage strain at a particular time t. Upon identifying this autogeneous shrinkage strain at a particular time t as well as drying shrinkage strain at a particular time t, we are going to add these two terms to find out what is the total shrinkage strain. Now let us see the loss increases because of creep of concrete. Now what is creep of concrete? Because of the sustained load, there will be certain amount of deformation of the member, and if this deformation of the member is going to reduce the dimension of the member, and in turn this is going to reduce the length of the tendon over a period of time. So in turn it's going to reduce the stress in the tendons. Now the code says that as long as the stress in the concrete does not exceed 1/3 of the characteristic compressive strength, creep may be assumed to be proportional to the stress. So creep strain is proportional to the stress. So stress in normal sense, how do we calculate? The similar way we can calculate the stress because of the creep, or the loss of stress because of the creep. Okay, the creep is generally found with the help of a creep coefficient. Now what is this creep coefficient? Let us see. The ratio of the ultimate creep strain to the elastic strain is defined as ultimate creep coefficient. This creep coefficient phi is given as epsilon cc times t by epsilon ci of t naught. Epsilon cc of t is nothing but the creep strain at a particular time t, which is greater than t naught, whereas epsilon ci of t naught is initial strain at the loading, whereas t naught is the initial time of the loading and t is the moment which we have to consider. The loss due to creep of concrete can further be calculated as epsilon cc times Es. We have to find out this epsilon cc, but what we have done is we have found out what is the phi value. Phi value is equal to epsilon cc by epsilon ci. So how can you get the value of epsilon cc? Epsilon cc is equal to 5 times of epsilon ci. So that's what we have written here. 5 times of epsilon ci times Es. What is epsilon ci? Initial strain at the time of loading, which is nothing but the stress by the modulus of elasticity of concrete. Further, this can be written as stress of concrete times Es by Ec is going to be the modular ratio times my phi value. So the creep coefficient phi is to be determined in this following manner. The creep coefficient phi t comma t naught is given by the expression phi naught times beta of t comma t naught. So for finding out the phi of t comma t naught, we have to find out the value of phi naught times beta of t comma t naught. So let us see how do we find out these terms phi naught and beta of t comma t naught. Phi naught value for 70 years can be directly taken from the code. Phi naught value for 70 years of time for ordinary structure concrete is given for different relative humidity values. So 50 relative humidity value and 80 percentage of relative humidity value, and for different notional sizes H naught values starting from 50, 150 and 600 mm. For these values at a particular time of loading T naught, I can find out the value of phi naught. So if I know this phi naught value, I'm supposed to find out this value of beta of T comma T naught. Or else if you want to find out the phi naught value in a more precise manner for your conditions. So how do I find out? So phi naught value can further be calculated as phi of RH times beta of FCM times beta of T naught. Phi RH is a factor to allow the effect of relative humidity. So this value is given as 1 plus 1 minus RH by 100 by 0.1 times cube root of H. This value is for the compressive strength less than 45 MPa. Similarly, this value, which is 1 plus 1 minus RH by 100 by 0.1 times cube root of H times alpha 1 whole into alpha 2, these values are for compressive strength more than 45 MPa. We already know what is RH. RH is a relative humidity value. So let us see what is this alpha 1 value. Alpha 1 value is 45 by FCK plus 8 to the power of 0.7. Similarly, alpha 2 value is given by 45 by FCK plus 8 to the power of 0.2. Beta FCM is a factor allowed for effect of concrete strength. So this value is given as 16.8 by root over FCK plus 8. Beta of T naught is given as 1 by 0.1 plus T naught to the power of 0.2. This is a factor which is allowed for the age at the loading of the member. Now, now we can find out. We have found. We can find what is find what is the value of phi RH. So we are supposed to find out what is the value of phi naught. We know phi RH value. We know what is the value of beta FCM, beta T naught. By substituting all these values, we are going to get what is the value of phi naught. But in this expression, we have found only the first term. Let us try to understand how do you find this the second term. Beta of t comma t naught is further determined as t minus t naught by beta h plus t minus t naught to the power of 0.3. So t, as we already know, is the age of concrete at the moment we have considered. T naught is the age of concrete at the loading, and T minus T naught is the duration of the loading, and beta H is a coefficient depending upon the relative humidity RH. So this beta H value is found as 1.5 times 1 plus 1.2 RH by H naught to the power of this to the power of 18 whole into 18 H naught plus 250. This value should be less than or equal to 1500. And this expression is valid only for 45 MPa or lesser grades of concrete. If your grade of concrete is more than 45 MPa, the same value can be determined in this manner: 1.5 plus 1.2 times RH by H naught whole to the power of 18 into H naught plus 250 times alpha 3. This value should be again less than or equals to 1500 times alpha 3. So RH is the relative humidity value, RH naught is 100% 100, and alpha 3 value is 45 by FCK plus 8 whole to the power 0.5. Now by knowing all these terms, we are going to find out what is the value of beta of H comma H, beta of T comma T naught. Now after knowing the beta of T comma T naught and knowing the value of phi naught, we can find out what is the value of phi of T comma T naught. Now knowing the phi value, we are going to find out epsilon Ci value, which is uh, further Fc by Ec. Now the whole expression is turning out to be phi times Fc by Ec times Es. Again, this term is going to be phi times modular ratio times stress in concrete. So now we have found what is the value of phi. So we are going to find out the modular ratio and multiply it with the stress in concrete. Now let us see one problem and try to understand. The problem is to determine creep as well as shrinkage. In this problem, we are supposed to find out the loss of stress in steel due to shrinkage and creep after 3 months. Okay, so the cross section is given as 100 mm by 100 mm by 300 mm, and this is by 5 wires of 7 mm diameter, and the eccentricity is 50 mm, and the initial stress in the tendons being 1200 newtons per mm square. He has also given that the relative humidity value is 80%. So the problem is like this. Okay, we have a pre-tensioned member, and in this pre-tension members, we have a pre-stressing force which is located at a certain eccentricity. This eccentricity value is known as 50 mm. This is the dimension. So we are going to find out the area of concrete. We are going to find out the area of steel. So we have got 5 wires of 7 mm diameter. So we are going to find out area of steel. Further, pre-stressing force is given as the stress in the steel times area of steel. Stress in steel is given as 1200 newtons per mm square times the area of steel which we have found here. So this value is going to be equals to 231 kilonewtons. So we have found what is the pre-stressing force value. Later let us find out what is the value of I, which is BDQ by 12, then Z. Z, as soon as we calculate the Z value, what comes in our mind is I by Y. Y is again D by 2. So the overall depth is 300 mm, so it's going to be 150. So this is a wrong perception. So we are supposed to find out the Y value or the section modulus value at the level of steel. So we are supposed to find out at this level. So my Y value will be equals to 50. So for Y value of 50, this value is turning out to be 4.5 times 10 to the power of 6 mm cube. Now let us find out the stress in concrete at the level of steel. The stress in concrete at the level of steel is equals to P by A plus PE by Z. Now this Z value we have found to be 4.5 into 10 to the power of 6, and P value we have some time ago found as 31 kilonewtons, and E value is 50 mm, and A value we have found as 30,000 mm square. Further, we are going to find out what is the value of Fc. This pre-stressing force by area, pre-stressing force times eccentricity by the section modulus at the location of the steel. Please keep this in mind. Further, we have found the stress in concrete at the level of steel. Now, further we are supposed to find out the loss due to shrinkage initially. For that, the loss due to shrinkage can be shrinkage strain times this is actually epsilon cs times es. Okay, so epsilon cs times es. So epsilon cs value, which is total shrinkage strain, is equals to epsilon cd plus epsilon ca. Epsilon cd is your drain shrinkage strain for 180 days as given in the problem. So let the initial days of drying shrinkage strain or the usage of structure is 28 days. So epsilon cd value at 180 days or 6 months is equals to beta ds of 180 comma 28 times kh times epsilon cd. So we are supposed to find out what is beta ds value, kh value and epsilon cd value. So beta ds value is 180 comma or 180 comma 28. So we are going to find 180 minus 28 by 180 minus 28 plus 0.4 root over h naught cube. Now we do not know what is h naught value. So h naught value is equal to 2 times AC by U. In this problem, what I have considered is my beam is exposed on these three sides, and in the top side I'm going to have a deck slab. So the perimeter which is exposed for atmosphere is considered as 300 mm or 300 mm plus 300 mm, and this is the 100 mm. So it's going to be 700 mm. So I know what is value of AC, area of concrete, which is 100 into 300 times 2 by 700 is going to be 85.71 mm. For 85.71 mm, the KH value is equals to, or for up till 100 mm, it's going to be equal to 1. Then beta ds of 180, 28 is given as substituting this H naught value here. So I got the value of beta ds value to be 0.32. Then epsilon cd value for a given grade of concrete. What is the grade of concrete which is given in this problem? Grade of concrete is 40 MPa. So for 40 MPa grade of concrete, epsilon cd value is equals to 260 into 10 to the power of minus 6. So epsilon cd at 180 days is equals to beta ds value times kh value times epsilon cd value. All this put together, epsilon cd value is determined as 83.2 into 10 to the power of 6 minus 6. Similarly, autogeneous shrinkage strain epsilon Ca value for 6 months is considered as epsilon Ca of 180 is equals to beta As of 180 times epsilon Ca. Beta As of 180 is equals to 1 minus exponential of minus 2 root over t. So this value is turned out to be 0.93. So I found what is the value of beta As. I am supposed to find out what is the value of epsilon Ca. So this value epsilon Ca from the table is determined to be 60 into 10 to the power of minus 6. Knowing this epsilon Ca value and beta As value, substituting this value, I am going to get the value of epsilon Ca for 180 days. So epsilon Ca value for 180 days is determined as 55.8 into 10 to the power of minus 6. Total shrinkage strain epsilon Cs is sum of autogeneous shrinkage strain and drying shrinkage strain. So autogeneous shrinkage strain value and drying shrinkage strain values are summed up and the total shrinkage strain is found. Upon knowing the total shrinkage strain value, I'm going to multiply it with the stress in steel or the modulus of elasticity of steel. Then I'm going to get the value of loss of stress due to shrinkage. So in this problem, I've got the loss of stress due to shrinkage to be equals to 29.19 newtons per mm square. So let us see how do we find out the loss due to creep. The loss due to creep is equals to 5 times Fc times modular ratio. This phi at a particular time t comma t naught is given as phi naught of beta of t comma t naught. So phi naught is equals to phi RH times beta of FCM times beta of T naught. Now let us find out what is the value of phi RH value. Phi RH value, because it's less than 45, we have taken the first expression, which is equals to 1 plus 1 minus RH by 100 by 0.1 times cube root of H naught. This value, upon simplification, I got RH value to be 1.45. Further, beta FCM is a factor related to compressive strength, so it's going to be 16.8 by root over FCK plus 8. So I got this value to be equals to 2. Uh, 2.4. Further, beta of T naught is a factor which is depending upon the age of loading, so it's going to be determined as 1 by 0.1 plus T naught to the power of 0.2. This value is turning out to be 0.49. By substituting all these values, I got this value to be equals to 1.71. Further, I am supposed to find out the value of beta of t comma ts. So I am going to find out this value. This value is equals to 180 minus 28 by bh plus 180 minus 28 whole to the power of 0.3. Now in this expression, I do not know what is the value of beta h. Beta h is equals to 1.5 times 1 plus 1.2 RH by RH naught whole to the power of 18 into H naught plus 250. Upon simplification, I could able to find this value of beta H to be equals to 440.22. Now I know what is the value of beta H, I know what is the value of phi naught. So beta H value I know, I'm going to find out what is the value of beta. Beta at 180 days I'm going to substitute and I'm going to find out what is the value of beta of 180 comma 28. So this is beta H. I'm going to substitute this beta H here and I'm going to find out what is the value of beta of 180 comma 28. So I got the value of 0.66. Phi of 180 comma 28 can further be calculated as 0.66, which is beta times phi naught, 1.71. So I got the value of 1.14. Now modular ratio value is ES by EC. I got this value to be 6.64. So I could able to find out what is the value of phi. I could able to find out what is the value of FC. I could able to find out what is the value of modular ratio. So substituting these values, I got the value to be equals to 77.739 newtons per meter. Finally, I would like to touch upon the total losses to be considered. Indian Standard Code has not discussed anything related to total loss, but let us consider as per the ACI standards. As per the ACI standards, it is said that the total losses can be outlined in the following manner. The percentages of loss for pre-tension members and post-tension members. For elastic shortening and bending of the concrete, it is 4% for pre-tension members and 1% for post-tension members. Creep of concrete is 6% and 5% for pre-tension and post-tension members. Shrinkage of concrete is 7% and 6% for pre-tension and post-tension members. Creep in steel is 8% in pre-tension as well as post-tension members. The total loss shall not be greater than or will be in the ranges of 25% for pre-tension members and 20% for post-tension members. Thank you.